Here, we have an example of a two-dimensional Clayton copula, visualized using scatter plots for different values of theta. These plots show how the copula behaves as theta increases, starting from a small value, then a medium value, and finally a large value, with the maximum shown here being theta equal to 8. Let me remind you that theta is a parameter that falls within an open range, starting just above 0 and extending to infinity. Looking at the scatter of points, you can see that as theta increases, the correlation between the random variables becomes stronger in the lower tails. The lower tails represent areas where the variables take on their smallest values. For instance, when theta equals 0.2, the scatter plot below shows a very loose arrangement of points. There's no significant correlation between the variables u1 and u2, or equivalently, between x1 and x2. When theta is increased to 1.5, the scatter plot starts to reveal a relationship in the lower tails of x1 and x2, where the values of u1 and u2 are close to 0. The pattern becomes more pronounced compared to when theta was 0.2. As theta continues to increase, the correlation in the lower tails becomes even more visible. For example, when theta equals 3, you can clearly see some alignment in the lower ranges of u1 and u2 near the value of 0. This alignment is more distinct than what is observed for theta equal to 1.5. This type of correlation, focused on the lower tails, is precisely what the Clayton copula is designed to model. Finally, when theta reaches 8, the correlation between u1 and u2 in the lower tails becomes very strong. The relationship between x1 and x2, specifically in the lower tails where these random variables take on their lowest values, becomes highly evident. In the lower left corner of the scatter plot, the points cluster together and overlap significantly. This indicates a very strong correlation. However, in the upper right corner, the points remain more dispersed. This shows that the correlation in the upper tail, where u1 and u2 approach values close to 1, is noticeably weaker. This contrast between the lower and upper tails highlights a key characteristic of the Clayton copula: its ability to model strong lower tail dependence while maintaining weaker dependence in the upper tail.